Hello everyone, thank you for watching my presentation. I'm Ahyeon Choi from Seoul National University. Today I'd like to introduce our systematic review on the neural mechanisms of musical illusions, investigated using EEG, MEG, and fMRI. Musical illusions are fascinating phenomena of how sensory input interacts with our cognitive processes. Typical examples include shepherd tones, the octave illusion, the scale illusion, and the speech-to-song illusion. These illusions demonstrate how the brain organizes sounds, often leading to perceptions that differ from the actual physical stimulus. As a brief example, let me introduce the scale illusion, which is one of the most well-known musical illusions. When zigzag melodic patterns are presented to both ears, principles of continuity or proximity can make us perceive them as either linear or arc-shaped patterns. This shows how our auditory system groups and interprets sounds beyond their direct input. Despite many behavioral studies on these illusions, their neural mechanisms have remained unclear and fragmented. So we aimed to systematically consolidate findings from EEG, MEG, and fMRI studies. We followed the PRISMA guidelines and searched databases such as PubMed, Web of Science, PsycInfo, and Scopus. After removing duplicates, we screened 28 articles based on their titles and abstracts. We then reviewed the full text but excluded studies that were not in English or not peer-reviewed and did not include neurophysiological data. We also found additional relevant papers through backward citation tracking. Finally, we included a total of 15 studies in our review. We organized these studies by the type of illusion stimulus and summarized the key findings by the neurophysiological method used. As you can see in this table, musical illusions involve two main aspects. First, in terms of temporal dynamics, musical illusions show altered mismatch negativity responses and increased zeta band synchronization between frontal and temporal regions, reflecting changes in early auditory prediction and mismatch processes. Second, spatially, we found that the auditory cortex, including the planum temporal and temporal gyrus, plays a key role in processing pitch and grouping. Meanwhile, the inferior frontal gyrus provides top-down modulation. Together with the supplementary motor area and the inferior parietal view, they form a network supporting auditory motor integration and predictive coding. These findings support predictive coding and sensory memory frameworks, illustrating how the brain uses stored auditory patterns to anticipate and construct percepts beyond direct input. Because musical illusions unfold progressively over time, we emphasize the need for continuous EEG analysis, such as temporal response function modeling, to capture these dynamic processes in complex auditory perception. Thank you so much for watching my presentation. If you have any questions or feedback, please feel free to visit my poster or contact me by email. I would be happy to discuss this work further.